In this video, we'll be highlighting the key distinctions between the different machine learning subdomains. In machine learning, there exist three main subdomains: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained using labeled data. In unsupervised learning, the model is trained using unlabeled data. And in reinforcement learning, the model is trained with the interaction of the environment. So in the supervised case, you can think about classification and regression problems. In the unsupervised case, you can think about something like clustering. And in reinforcement learning, we have a state where the agent takes an action, it interacts with the environment, getting a reward, which takes us back to a new state, and we continue this loop. To go into more detail, in supervised learning, we learn from labeled examples provided by a supervisor, which is why it's called supervised learning. The goal here is to generalize to unseen cases, and some examples of this include in regression, predicting housing prices, so our input would be the size of the house, the age of the house, how many rooms there are, etc., while the answer that we give it is the price that we want it to predict. In the second case, we can detect dogs in photos, so doing object detection, where the input would be the photo, and then the answer is the coordinate of the dog in the photo. In the second case, in unsupervised learning, we want to find hidden patterns and structures in unlabeled data, so there's no reward maximization involved, and an example of this is making friend recommendations, for example Facebook, where we want to cluster people based on their interests, locations, and mutuals. So if you think about two people that have a lot of friends in common are more likely to be friends, or if two people that are both on the same soccer team are more likely to know each other. In the final case, we have reinforcement learning, which is focused on maximizing a given reward signal. So here we have no explicit labeled data, however we learn from trial and error. So an example of this is teaching a robot how to self-park, where we have a positive reward for good parking and we have a negative reward for hitting anything while it's parking. So over time, it learns how to better and better park. If you found these descriptions helpful, please consider following us on YouTube, Instagram, and Patreon. Thank you.